Welcome, dear students, to another very important topic, that is the Markonikov's rule. Dear students, Markonikov's rule is the rule which is only applicable to addition reactions. This rule is not applicable to substitution or any other type of the reaction. It is only for the addition reactions. And not for all the addition reactions, but only those addition reactions in which two conditions are met. Number one, there must be an unsymmetrical reagent, and that should be added to an unsaturated hydrocarbon. Now, what is meant by the unsymmetrical reagent? Dear students, a reagent which is heteroatomic and polar, that will be considered as an unsymmetrical reagent. For example, all halogen acids, water. This is heteroatomic as well as polar. Similarly, it is also heteroatomic and polar. So both these, they are unsymmetrical reagents. But if you see the hydrogen molecule, it is, my dear students, homoatomic molecule and it is a non-polar. So it will be symmetrical. It is not unsymmetrical. That's why whenever you will be adding hydrogen to any unsaturated hydrocarbon, there will be no Markonikov's rule applicable there. The unsymmetrical unsaturated hydrocarbon, what does it mean? It is the hydrocarbon in which unsaturated carbons have different number of hydrogen atoms. That unsaturated hydrocarbon in which the unsaturated carbons have different number of hydrogen atoms, it will be called as unsymmetrical unsaturated hydrocarbon. For example, starting from the simplest alkene, that is ethene. In case of ethene, both unsaturated carbons, they are having equal number of hydrogen atom. So that will be a symmetrical alkene, and Markovnikov rule will not be applied to it. Now let us move towards propene. This propene has two unsaturated carbons and both have different number of hydrogen. It has two hydrogen atoms, it has one hydrogen atom. So it is an unsymmetrical unsaturated hydrocarbon which will follow the Markovnikov rule when some unsymmetrical reagent will be added to it. Now let us consider a last example, that is 1-butene. 1-butene is again unsymmetrical because of the different count of the hydrogen atoms with both unsaturated carbons. But 2-butene, my dear students, it is symmetrical because it has equal number of hydrogens with the two unsaturated carbons. So it will not be following the Markonikov's rule. Propene and 1-butene will follow the Markonikov rule because they are unsymmetrical. Ethene and 2-butene will not follow because they are symmetrical unsaturated compounds. Now let us see what the Markonikov rule says. Suppose that we have propene and we want to add hydrogen bromide to this propene. Now, my dear students, the reagent is unsymmetrical and this unsaturated compound is also unsymmetrical. So, if both will be unsymmetrical, then Markonikov's rule will be applicable. If any one of them will be symmetrical, then Markonikov rules cannot be applied. In that case, there are two chances. The first chance is that the positive part goes to the carbon with greater hydrogen and negative part goes to the carbon with lesser hydrogen. In that case, you will get a product that will be CH3, CH, CH3 beer, 2 bromopropane. And the second possibility is that the positive part goes to the carbon with lesser hydrogen and negative part goes to the carbon with more hydrogen. And in that case, you will get 1 bromopropane. Now, which one of the following will be the correct product? Markonikov rule will help you in this case. According to Markonikov rule, it says that the positive part of the reagent should go to that unsaturated carbon having greater number of hydrogens, and the negative part of the reagent should go to that carbon, or it should attach to that carbon having lesser number of hydrogen. So according to Markonikov rule, the positive part should get attached to that carbon with greater number of hydrogen. So in this case, this H positive should get attached to this carbon. And the negative part should get attached to the carbon which has lesser number of hydrogen. So negative part should be attached to this carbon. And the product formed, or you can say the major product formed, in this case, that should be the 2 bromopropane. There will be 1 bromopropane formed in this reaction, but that will be less than 1%. So that will be a minor product and it will be ignored. The major product will be formed according to the rule as stated by the Markonikov. Now, why this happens? Let us see the mechanism of this reaction. My dear students, when some halogen acid is added to alkene, first of all, the halogen acid gets ionized. And when it will get ionized, it will form a proton and negative bromidine. Now, in the second step, first of all, the electrophile attacks the pi electron of the alkene. Electrophile is H positive. It will attack the pi electrons, and again there will be two options. Option number one, if this H positive gets attached to this carbon, what will happen? CH3, CH2, and this will get positive. A carbocation, which is primary carbocation, is formed. The second chance is that hydrogen goes to this carbon. In that case, you will get CH3, CH, CH3, and a secondary carbocation is formed. Now you already know the stability of the carbocations. You must have a concept of the stability of carbocations, that the secondary carbocations are more stable as compared to the primary ones. It means when this electrophile will attack on the pi electrons of this alkene, then the stable carbocation will be formed. And that stable carbocation is the secondary one. This carbocation is formed but in a very minute quantity, so we will ignore it, and we will say that the more stable carbocation is formed. Now, in the last step, this positively charged carbon will be attacked by bromidine, and you will get CH3, 2 bromopropane. So now we get to know why the negative part goes to the carbon having lesser number of hydrogen, because the carbon with lesser number of hydrogen gets positive charge to form a stable carbocation, and when the carbon with lesser number of hydrogen will get positive charge and it will form a stable carbocation, then the negative part of the reagent will be automatically attracted towards this positive carbon. So basically, the Markonikov rule is based on the stability of the carbocation. Markonikov rule says that carbocation is formed which will be more stable. In this case, primary will not be formed, secondary carbocation will be formed. And in case of secondary carbocation, the carbon with lesser number of hydrogen will be having the positive charge. Then it will attract the negative part of the reagent, and the negative part of the reagent will get attached to that carbon which will be positive with lesser number of hydrogen, and automatically the positive part will go to that carbon which has greater number of hydrogen atoms. And in this way, the product of addition reaction in which an unsymmetrical reagent is added to unsymmetrical unsaturated hydrocarbon is decided by Markonikov rule on the basis of the stability of the carbocation. So that was all about the Markonikov rule. If you feel any problem, feel free to ask in the comment section. Till then, take care.